Hello everyone! Welcome to our Mathematics of Finance tutorial. Hope you enjoy it!
Mathematics of Finance. The Mathematics of Finance concentration studies the foundations of financial theory, including asset pricing and financial institutions. Students learn how financial market works, how to price asset and measure risk, and how asymmetric information between buyers and sellers impact markets. Simple interest is an interest computed on principal in specified time. It is charged as a percent of the principal for a definite period of time, and rates are stated in terms of 1 year unless otherwise specified.
Interest is a percentage of some amount of money. It could be an amount of money paid to someone for the borrowed money, or it could be the amount of money received from somebody by lending money.
A man put his 500,000 in an investment earning with an 8% interest. Determine a man's interest earned and his total money at the end of 15 months. Interest is equal to principal times rate times time. The principal is equal to 500,000, the rate is equal to 8% or 0.08%, and the time is equal to 15. The equation is 500,000 times 0.08 times 15 over 12 is equal to 50,000. And to find the maturity value is equal to principal plus the interest. 500,000 plus 50,000 is equal to 550,000.
Rate refers to the percentage of the principal year per year. A man borrowed 120,000 from lending institution and promises to return 140,000 after 10 months. What was the interest rate change? The interest is equal 20,000. The principal is 120,000 and the time is equivalent of the 10 months. To find the rate, the formula is rate is equal to interest over principal times time. 20,000 over 120,000 times 10 over 12 is equal to 0.2 or 20%.
Time refers to the length of time.
Determine the time when 500,000 invested at 15% simple interest and will accumulate an interest of 16,875. The time was being asked in the question, so the formula for time is equals to interest over principal times rate. Solution in the question. Time is equals to 16,875 over 500,000 times 0.15. The total is 0.225 or 2.25 years.
In solving the time between two dates, there are two ways to compute for the number of dates between two dates, which is the actual time and the approximate time. The actual time considers all the days between two given dates, and the approximate time assumes that every month counts 30 days. In interest between two dates, there are four types of it. First, the exact interest at actual time. Second, the exact interest at approximate time. Third, ordinary interest at actual time. And the last, ordinary interest at approximate time. In a given problem, find the exact and ordinary interest of 50,000 at 2 3/4% simple interest using both the actual and approximate number of days from April 11, 2017 to February 19, 2018. So the solution, first, we have to identify the number of days. In the actual time, starts from April, there is only 19 days, May 31 days, June 30, July 31, August 31, September 30, October 31, November 30, December 31, January 31, and February only 19 days, which is equals to 314 days. In approximate time, April consists of 19 days, From May to January equals to 30 days, and from February equals to 19 days, which is 308. The principal is 50,000 and the rate is 2 3/4 or 0.0275. At exact interest at actual time, 50,000 times 0.0275 times 314 over 365. The interest is equal to 1,182.88. The exact interest at approximate time, 50,000 times 0.0275 times 308 over 365. The interest is equal to 1,160.27. In ordinary interest at actual time, 50,000 times 0.0275 times 314 over 360. The interest is equal to 1,119.31. And in ordinary interest at approximate time, 50,000 times 0.0275 times 308 over 360, the interest is equal to 1,176.39.
Maturity value. A man made a time deposit of 1 million pesos in a bank, which accumulate at 6% semi-annually for the first 2 years and 5% compounded quarterly for the next 3 years. Find the compound amount at the end of each term. Here's the formula. Maturity value equals to principal times 1 plus interest raised to n minus 1. Maturity value equals to 1 million times 1 plus 0.03 raised to 4 minus 1. 1 million times 1.03 raised to 4 minus 1. The total for 2 years is maturity value equals to 125,508.81. Here's the formula for 3 years. Second maturity value equals to principal times 1 plus interest raised to n minus 1. Second maturity value equals to 125,508.81 times 1 plus 0.0125 times 12 minus 1. Second maturity value equals to 20,176.11.
Finding the nominal rate in compound interest. Rate equals to m times maturity value over principal raised to 1 over n minus 1 times 100%. For example, at what rate compounded quarterly will 9,000 will accumulate to 12,500 in 5 years. Maturity value is 12,500, principal is 9,000, m is 4, time is 5 years, n is 20. Rate is equals to 4 times 12,500 over 9,000 raised to 1 over 20 minus 1 times 100%. The answer is 6.62%. Second example, how long will it take for 15,000 to accumulate to 17,500 at 2.5% compounded monthly? Time is equals to log maturity value over principal over m log times 1 plus interest. Maturity value is 17,500, principal is 15,000, m is 12, rate is 2.5% or 0.025, L is 0.00208. Time is equals to log times 17,500 over 15,000 over 12 log 1 plus 0.00208 is equals to 6.18.
Finding the present value or principal in compound interest. For example, find the present value of 12,850 due in 3 years if the interest rate is 8% compounded quarterly. The formula is principal is equal to maturity value over 1 plus interest raised to n. Maturity value is 12,850, n is equal to 12. Interest is equal to 0.02. Principal is equal to 12,850 over 1 plus 0.02 raised to 12. The total is 10,132.14. The next example is find the present value due in 5 years and 5 months. If money is worth 6 to 5% compounded monthly. N is equal to 65, maturity value is equal to 150,000, interest is equal to 7.41304294. The formula is principal equals maturity value over 1 plus interest raised to n. The total value is 106,153.89. We suggest to use scientific calculator